Hello, so we are on to winds. I had a little snafu, so make sure you get onto the right page. We're looking at winds, the essential question, what causes that? What causes winds? And how do local winds and global winds differ? Where are the major global winds located? This is going to be on page 12. All right, let's flip over to the anticipation guide. We're going to do 7 and 8. Just write true or false on the left-hand side. Doesn't matter if you know it or not. Just try and figure out, see if you actually know something you didn't know you knew. All right. Wind is caused by differences in weather. True or false? Number 8. Global winds between 60 north and south latitude in the poles are called easterlies, and they blow east to west. Explain. Or true or false, sorry. All right, let's go back to the notes. Wind. Wind is air in motion, moving air. And it's caused by uneven heating from the sun, uneven heating of the earth from the sun. So you can see right here in my nice little picture that the sun goes down, it gets reflected a little bit, and it hits the ground and is absorbed by the ground, by the surface, and then you see it's absorbed by clouds, it's reflected. A bunch of different things are happening. And with the uneven heating, what I mean by that is the angle that the sun hits the earth to heat it up. One of the things I brought up in class was in, say, like Alaska, there's about a month in the year, winter, that they don't have the sun. The sun doesn't come out at all. It's nighttime the whole time. Whereas in, like, say, the summer, it's sunny all day. Even though it's like it's almost at like sunset-ish, but it's still sunny. So during those times, like when it's totally dark out, it doesn't get really warm. But when there's sun all day, it could get a little bit warmer. And just like around here, we don't get the sun all the time beating down on us. So it's not always warm. Whereas at the equator, the sun's always hitting directly, so it's nice and toasty. We don't have the same amount of sun the whole time, so it's uneven, which causes the wind to move due to density and how dense it is. The less dense, the warmer it is. The more dense, the heavier it is. And because of this, you get local breeze. So remember, we're looking at local breeze versus global breeze. So local breeze would be, what's it doing outside? Like, what's the wind outside at the moment? Local winds are uneven heating of Earth's surface within a small local area. Like right now, looking outside, what is the wind? That's local. There are two types of local that we could really look into right now. One is called a sea breeze. A sea breeze happens during the day. Why does this happen? Well, the land heats faster than water due to heat capacity. And because it heats faster, the air over the land gets warmer. It gets warmer faster. So it rises up and it goes out over a body of water. And over that body of water, it's cooler. So all that warm air, all that warmth, all the air loses the warmth. It cools down because, number one, it's going up higher. The higher you go, the cooler it gets. But it's also over the water. So it starts to sink. It's less dense, or more dense. It starts to sink down. And as it does that, it starts to push over the land because, cold is heavier, more dense, so it can push out that warm air, which then goes back over the body of water. All right, so this is like when you go to a beach and you're sitting there and you have that breeze coming at you. You notice that's during the day. There's a night one. At night, you have something called a land breeze. So one of the things I want to bring up, sea breeze, sun. Land breeze, lunar, like a lunar eclipse that happens at night. So land breeze occurs during the night because, again, remember, land heats up faster, which means it cools faster than water. So if it's cooler than the water, the body of water, and that cool air will then be sinking over the land and pushing out over the water where it heats up due to the water, and then it comes back around and gets pushed. So you have this land breeze. The breeze is coming from the land out onto that body of water. And it creates, oh, it doesn't create a sea breeze. It creates a land breeze. Oh, wow. There's a typo. I apologize. All right. Global winds. So we have the local sea breeze, land breeze. Now we're going to look at global winds. They are created by, again, the uneven heating of Earth's surface. But looking at this picture, you can see, hey, they're not going in straight lines. No, that's because Earth rotates. So the winds don't go at a straight line. Another reason for this, or the reason for this, is called the Coriolis effect. Winds curve because of this Coriolis effect. And in the northern hemisphere, you'll notice that it's going from right to left. So it's going in this counterclockwise movement. In the southern hemisphere, it goes in a clockwise movement. Think of it, the Earth spins, and it's kind of like when you're on the merry-go-rounds at a playground. If you were to take a ball on the merry-go-round when you're going in circles, and you to throw it, you throw a normal ball, it goes straight. Well, when you're on this, when you throw it, it appears to be curving. That's the same thing that's happening. But it's not curving. It's going straight. But it's, as you are going straight, I'm throwing it like this. I'm throwing it straight, but I'm turning. So it looks like it is moving to the side, right? That's what's going on with the winds. And because of this, we now have wind belts. And we're going to really look at trade winds, westerlies, and easterlies. I apologize. And you'll notice that there are lines right here. These right here, the polar fronts, the horse latitudes, intertropical convergence zone. So we're going to use those to kind of break up the trade winds, westerlies, and easterlies. And some of the ways we break them up is we use latitude angles. Latitudes are the invisible angles or degrees separating each chunk of the Earth, right? So we're starting at 0, that's where the equator is, up to 90 degrees, which is the poles. And they are measured in degrees and like angles. And we're going to use these by 30s. We're going to look in chunks of 30s for these winds. The first set we have are the trade winds. The trade winds are down near the equator. They're going from the equator to 30 degrees, and they go from east to west. So one of the ways you can remember this is traders. They want to sail their ships, and they sail their ships between 0 and 30 using the east currents, the east winds, to blow their sails. Why that's called trade winds. And a lot of it is when they were over in Europe, they would want to sail across to the Indian Islands, but we're in the way, so they use those winds to travel over to the Americas. All right, well, how do they get back? Because they're using the winds, and from 0 to 30, they're going east to west. I got to get west to east. So what are they going to use? The westerlies from 30 to 60 degrees. So from here to here and here to here, you're going east to west. From here to here, you're going west to east, the westerlies. And that blows them back from the Americas back over to Europe. And then at the very, 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 very tippy top, from 60 to 90 degrees, either north or south latitude, you're going to have the easterlies. Again, you're going back east to west. So east to west, you have the trade winds and the easterlies. West to east, you have the westerlies. All right, quiz time. This is going to be quiz number 4. Label it winds. 1, 2, 3, 4, 5. Pause as needed. All right, this type of wind blows between the equator and 30 degrees north and south latitude. Is it jet winds, trade winds, easterlies, or westerlies? This one, remember, from equator to 30, this is going to be the trade winds. Wind is horizontal movement of air caused by what? Is it uneven heating of air, the altitude, the weather, or the difference between night and day? This one is going to be the differences in uneven heated air. All right. This type of wind blows between 60 and 90 degrees latitude, either south or north. Jet winds, trade winds, easterlies, or westerlies. These ones go from 60 to the poles. It's going to be the easterlies. Trade winds blow from what to what? These ones are going to be either east to west, west to east, north to south, south to north. Trade winds, remember, we're going from Europe to America. It's going to be east to west. Sea breeze. When does this occur and how does this occur? Is it at night from ocean to land? During the day from ocean to land? At night from land to ocean? Or during the day from land to ocean? So a sea breeze, sea, sun, day, and it's going to be from the ocean, from that body of water, to land. All right, let's hop on over to the anticipation guide. Number 7, wind is caused by differences in weather. This is false. On the right-hand side, you're going to write false. And then in the explain, wind is caused by the differences in the heating of Earth's surface by the sun. All right, number 8, global winds between 60 north and south latitude and the poles are called easterlies and blow east to west. This is absolutely true. Along with the trade winds, they blow east to west. And that's due to the Earth spinning and the winds curving due to that. And why? That's Coriolis effect. All right, the summary. Winds are caused by uneven heating of Earth's surface by the sun. How do local winds and global winds differ? Local winds include sea breeze during the day from water to land, and land breeze happening at night from land to sea. And global winds include easterlies and trade winds, which go east to west. And global winds include westerlies that go west to east. The major global winds are located. So trade winds are is a global wind found from the equator to 30 degrees that blow east to west. Westerlies are found from 30 degrees to 60 degrees latitude, go from west to east. And easterlies are global winds found from 60 degrees to 90 degrees latitude that blow east to west. All right, that is it. If you have any questions, don't hesitate to ask, and I hope you guys have a great day.